My name is Carlos Busso. I am professor at the Language Technologies Institute at CMU. I am the director of the Multimodal Speech Processing Laboratory. Our laboratory focuses on understanding, recognizing, and synthesizing human behavior. As we speak, we convey more than words. Speech communicates our emotions, our intentions, our desires. It indicates turn-taking patterns and nonverbal behaviors to clarify our message. We unconsciously mirror the behaviors of others, an important phenomenon called entrainment. All this information is simultaneously conveyed in a complex but natural way, dictating how we interact with others. Our laboratory is interested in understanding how we communicate with each other and use this insight to build algorithms that can robustly recognize and synthesize human behavior. In particular, we focus on emotion, which is crucial for human interactions and human-computer interaction. Emotion plays a crucial role in how we communicate with others. First, it influences our decision-making process, making a key role in our cognitive reasoning process. We externalize our emotions in our speech, facial expressions, and other communicative channels. Others can perceive our emotions when interacting with us, dictating how they will react to us. We believe that understanding users' emotions can have a clear benefit for human-computer interactions, including adjusting systems and making interaction more engaging. Emotion can play a crucial role in the context of a speech task. Emotions, speech affect acoustic space, changing the features. As a result, the performance of systems, including automatic speech recognition, speaking verifications, language identifications, are all affected. Also, emotions change the meaning of and intentions of the message. Therefore, if we are designing a spoken dialogue system or a conversation AI, recognizing emotion is crucial to understand the real meaning of the interlocutors. For example, recognizing emotions can be useful to clarify ambiguities in the message. One of the areas that we are particularly interested in the use of speech emotion recognition is in healthcare. As an example, speech emotion recognitions can provide useful information to improve the prognosis of several mood disorders, including PTSD, schizophrenia, depression, and bipolar disorder. With new speech-based devices at homes and at workplaces, it is now possible to implement longitudinal analysis of mood changes through the week, which is not currently possible with existing medical procedures. For example, detecting changes in emotions in patients can lead to more targeted interventions and better treatments. In the context of security and defense, we're interested in using speech emotion recognition systems to improve the work of the intelligence community. An example is content triage. The intelligence community is tasked with reviewing massive amounts of data every day. Speech emotion recognition systems can prioritize the analysis of recordings that are more likely to convey targeted scenarios, such as threatening behaviors. These technologies can be useful in the context of social interactive agents that recognize and respond to users in more human-like behaviors. The synthesis includes not just expressive speech, but also nonverbal behavior or nonverbal information that is tightly synchronized with the speech. In this context, generalizing emotional embeddings can be very effective strategies to model emotions. Speech is just one of several modalities that we use to convey emotions. We also use facial expression, lexical information, and body posture. In fact, multimodal communications are natural ways of interacting with others and with systems. Studying multimodal communications can be instrumental in human-computer interactions, autonomous systems, entertainment, and healthcare. We're interested in understanding how emotional information is conveyed across all these modalities and the temporal interplays across modalities during the externalizations of emotions. We aim to identify insights to help us build more robust multimodal systems. For this vision to succeed, we need to address key challenges. We're currently working on speech and emotion recognition models that generalize from one domain to another. A particular case that we are interested is in cross-lingual emotional recognitions, where models trained in English, where there are enough resources, can be effectively used in recordings in a second language. The challenge is how to mitigate linguistic and cultural differences. We are also interested in the temporal modeling of emotions, where knowing the current emotional state of the user should help predict their future emotional states. There are also opportunities in the area of multimodal machine learning. First, it is important to identify solutions that are robust, even when partial information is available. This scenario is likely to happen in real deployment of a multimodal system, where occlusions and lack of speech is expected to occur. With all the unlabeled multimodal data, an open challenge is how to obtain descriptive multimodal feature representations. Finally, several applications require similar multimodal solutions of the ones that we're using for emotions, including audiovisual speech recognitions and in-vehicle safety systems. We're also interested in exploring these areas.